So welcome everyone for this session. We'll talk to you about memory profiler that we experiment with our company in Proginov. So before to start, some words about Proginov. So we are a French company based in Nantes. So we develop our own software that we also integrate and host ourselves. Our application cover a lot of jobs, so to help all of our customers. And some numbers about hosting and monthly connection and concurrent uses. As you can see, our workforce. So we are about 350 people currently. You can see that we've got a lot of developers in our company. About 75% of them are OpenEdge developers. So we have to help them and to have some norms to have a good productivity. About us, I'm Adrien Fraisse. So I'm Progress developer at Proginov since 2012. I'm right now in the DevOps team, so I'm mostly of my time working on the tools for the developers.
I'm Patrice Perrot. I'm a developer since 2001. I'm working on performance since 2005, and I'm a DBA since 2010. Okay, well, we'll speak about memory profiler. So what is it? How we detect a memory leak before this tool, this feature, and how it's designed, how we work with him, what does it use. So.
Okay, so what's a memory leak? So if I go to the definition, it's increasing an uncontrolled memory occupancy caused by not freeing unused space. So if you create an object and you don't delete it, you have a memory leak. For example, in this code, you can see that I create a buffer right there. An error is raising right there, so I can't delete the object, so I've got a memory leak. We've got some problems with that our company. The application was running on 32-byte sessions, and we've got with new heavy component graphical some problems. So we have some crashes with the memory. We request Progress to help us because we want to analyze those problems, and we have some problems to detect them. So Progress give us in beta the memory profiler, so we could launch it and use it to analyze our programs.
How to detect a memory leak currently? In the previous version, we use those sessions, which is a session, first object, dataset, data source, and next sibling properties to work on the list of the current instantiated object. So we can have a list of each element with its number in the memory of the session. But it was not always able to know what procedure instantiate it. So where is the memory leak? We don't know. And what was the weight of each object, which was very difficult. And also, we have to run it. If the session crashes, we are not able to run it. The second possibility is to use the log manager and to analyze its log file to know which are the elements still in an active state. We are able to know the instantiating procedure, but this file could be huge, very huge. Its threshold and its maximum number of files could be a limitation. If the first file which instantiates the object is deleted, we have nothing. And the log manager have a footprint also.
Okay, so about the design of the memory profiler. So Progress integrated to allow the analysis of the memory on the AVM. So you can see it permits to have detail on the consumption and the allocation of the memory. You can activate it since 12.8 in all versions of 12.8. The front-end still under development by Progress. So at Proginov, we develop our own front-end waiting for the one designed by Progress. And Team Sargent presented 2 years ago at the Puck Challenge. We put the link of YouTube. If you search it, you could find it. And there is a session Friday made by Sanil Jardosh. So feel free to go to have some details about memory profiler.
How it works. So first thing, you cannot activate it on the fly. You have to specify it when you start your session. The result is in an OEMP file. Data are written on the fly in this file. It's a snapshot by snapshot. It's snapshot, take a picture of your memory. There are several ways to deal with. There is an automatic mode with the snapshot create every X second, or a manual mode when you're asking for snapshot. And you can combining the 2 operating modes.
Okay, so about the OEMP file, like say Patrice, the file is writing the whole session, so the data generated on this file grow until the session is leaving. So it could be large, of course, if your session is during a long time. So you have to have a look about that because it could give some problems sometimes. And about the performance, there is a small footprint for us, so it's not a problem to activate it because it's slower, less than 5% on a session.
So how to activate it? So you have to specify the profile memory parameter with its config file on the Provin command line. It does not work with the startup.pf. The config file has 2 lines. The report dir, which is the directory used to write the OMP file, and the number of seconds between 2 snapshots. If you specify 0, you are in a manual mode. And to create a manual snapshot, you have to use this command and specifying the labels that you want to see in your profile session.
Okay, so we will show you 3 use cases that we've got in Proginov. So the first one is more for the development team. So we use it to analyze a specific program. So the developer make his program, then he run it to analyze the specific program in manual mode. So you start the analyze, you launch your program, then you stop the analyze, and you go to check the file, check the OMP file to see if you've got memory leaks. My test case will be this one. So I've got an order list who got some orders with some product used by customers. And in my test, I've got 3 customers, Bob, John, and Dolly. Okay, so let's go for the demo. So our screen to analyze the OMP file. So we've got 2 lists. The first one is sharing files from other developers. So it could be good to help the other developer to analyze the file because sometimes they call us to have some help. So we could check those analyze on this list. So I can see only mine. So for my test, I will check those two analyze. The first one is with the memory leak, and the second one is without the memory leak. So if I show you some code, you can see I've got here some snapshot took by the code. If I show you in my program, you will see those labels like we show you with the command before in the presentation. So we launch this program with the snapshot in manual. And so if I show you the result, I can go for a diff, sorry, so beginning and the end. And if I go to the diff, I will show you only the diff right there. So here, you can see the object type that stay in the session. So I can see that I've got 3 TT and 10 ABL objects. So if I go to the detail on the right, you can see I've got 3 orders that use 70 megabytes of memory. And if I check under those 2 lists, I can see one by one those objects. So I can see the order, I can see the product, and I've got the call stack right behind, and so you can see where those objects are created. So it helped me to know that I've got memory leaks, that those objects are not destroyed, and so I can go into my code to check where these objects are not destroyed. So that's for the developer experience and for this first use case.
Okay, and we also use it in production, so it's more my part of the business. So we're hosting a lot of our clients and in our cloud. We have batch process which checked every 30 minutes the amount of memory consumed by each session. And if this memory is above our threshold, then my team will receive an email like this one. As you can see, there is my name. It was a test. My name, it was on this box, and this is my PID. And after this, what I do, I'm connecting on this machine, and I'm looking if the issue is still active. And as you can see, on the task manager, I'm consuming around 500 megabytes of memory. So the issue is still active. So I'm going on the report dir of the mem profile. So I've got 2 OMP files which are present. And as you can see, they are very small, 7 kilobytes. But this is wrong, because the session is still active, so it's still writing in it. And when I will copy and paste it elsewhere to analyze it, it will be very, very huge. So, as Adrien showed us, it was my tool screenshot of my tool when I did this session, take this picture. So there is my new session. And what we do, we are setting names on each session because it's easier for us to have a look 3 or 5 weeks after. We are always able to know what was this session. Yes. So, yes, I load it. It takes more time to load a memory session because I have a leak. And this takes some time. So, demo. That's just to show you the result. The snapshot. Yes, it was a session, so we integrate this session on EaseDB. And I will select one of the last snapshot. Yes, it's going to load. So as you can see, there is a huge number of dynamic buffer and dynamic query which are in the memory. And as you can see, the amount of memory is relatively huge. So I prefer the code view, the block view, I would say. And as you can see, I will show by memory scope, which is more interesting for me. And so I've got, in my view, which is my DBA view, I would say, I can order the element by the block, the source code, which consumes the more memory in the session. So as you can see, it's always on this session. And as you can see, there is a lot of memory and yes, model. Yes. And yes, model. Oh, yes. We've got all the dynamic object. And I will go to type again. It was more easy for you. I deselect this and just par memory used. Yes. And as you can see, you've got one dynamic query with more than 10,000 elements and two dynamic buffer, SHIP2 and state, with 10,000 elements in memory, with this amount of memory consumed. So, like Adrien said, we can have a look on what was the line and the block of the source code which created. So I just an email to write and send it to the development team, and they will do what they have to do to decrease this issue. So we use local and remote DB. We use local DB for personal analyze, and for example, for a case like the previous, I will load the session on my local DB, and not on the remote DB, which are sessions that we shared between all the team and all the society. So we have the possibility to transfer, I would say, a session between local and remote and local, because it will help us to be faster, because when you create a large amount of data, it's very faster to work in local mode.
For the record, the file that Patrice opened right before, we tested before on the remote database. To open the file and analyze the file, it was about 5 minutes to open the file. In local, you saw it right before. It made maybe 5-6 seconds to open. So that's why we made this option. Yes, we also made this option because with around 100 sessions in the DB reached the 2 GB. So it could be very huge for DB, so it's faster for us to make local analyze, make the analyze, drop this analyze, and only shared in the cloud DB what is interesting for all the society. And for our local DB, it's very fast to produce the DB and recreate a new one, which is empty. So I've got another demo for you. So I will run a program with the profile memory with this config file. I will start one. Yes, it's this one. Yes. So it will take some time to make a significant memory leak, and we will analyze it just after. We don't give you the clue between TT good and TT bad. Who is bad and who is good? Yes, but yeah. Did someone of you have already this issue? No. Too many index on time table. Yes, I reached the.
It's not a memory leak, yes. So, yes, first thing, I will correct this. Yes, TT good, TT good. TT good. It was just create 3 term tables with no undo, nothing else, so it's not from this. So if I'm lucky, I will have a Patrice. No. Generally, this issue is due to too much, I would say, persistent source code in memory, so I have too many. And nothing there, no persistent.
So this kind of analyze was what we are doing in the first time. And so now Patrice will show you with the memory profiler what we've got as information and data to analyze and find better problem. Because as you see, and as show Patrice, we only saw TT good with the protrace, the debug alert message, so we can't find where is the problem.
Yes, if we are lucky, we probably have what we want to show you in this file. No. This is what was this one. Oh, yes, so view one memory profile. It's this one, the last one. If I go on one of the last, you can see where is the issue. I've got more than 6,000 number of my term table in memory. So with this memory profiler, you can also deal with this issue, which is very hard sometimes to correct and find the root cause. Here there is no absolutely easy to deal with. I know which is the source code, and if I go to this source code, I will see what is the issue. TT bad. In fact, TT bad is defined without no undo, and we are running this source code in transaction. So the term table is deleted until when the transaction ends. So each time I run it, I've got this 5 index, which is still in memory, still active. So it's why I reach the limit of 32,000 index on my term table.
Okay, so what progress already presented? Like I said at the beginning of the presentation, so that's the front end that progress is developing currently. So as you can see, it's prettier than ours. So that's why we are waiting also this front end, so we can use it as everyone. So that's 2 screenshots of the progress memory profiler. About improvement perspective, of course, the new UI. I explain why, but the program that we made was to help us right now with the tool that we've got in beta. So the new UI, we are waiting of the progress web view. We will also develop something in our tools in Proginov. We also want to have a continuous integration of OMP file because right now it's only manual. We are not doing it every time. We only do it. We only are doing it on some case that we know we will have memory leaks. And the most part of the thing we want to do is training of our development team because we are a few people in Proginov that use the tool currently. So we want to train all our development teams to use it because we want to have less memory issues. And of course, we want to include it in our quality process.
So we ask also few things to progress. We will have, like we said, other tools on the market. We want to link memory consumption to object and not only to 3 node. It could give an aggregation of the memory leak kept by every object. That we also want it to be able to enable exclusion of progress of system object and handles. Because when development team do, I will say, really unitary test, it could be 20 or 30% of the object which are in memory, which are progress object. And for young developers, they don't know what is this object, and they are looking for this object, trying to delete it, and no, you do not have to do this. What could be interesting also, it's visualize object references. It will be better understanding of the inefficiency of the garbage collector, and it will also allow me to have a selection on the orphan object. If I select only the orphan object, I will say 90% of the job is done. I have just to have a look on the source code, which is under, and it will be easy for us. During a differential analysis, it was to propose some subset of objects like a created, deleted, remaining object to be like other object, the tool in the market. Alors, before I will show you, because we have a lot of time, I will show you what is, I will say, a normal session, what we analyze. Yes. Yes, before optimization. So just to add something like this avec a huge number of elements on each shown is selected. And as you can see, there is big number of elements, and when you have to deal with this, find what is the root cause of the memory leak, it could be very difficult because there is a lot of data to show. What we did not show, it's this one, yes. There is a scope memory, which Progress gives us, and we are able to, for one, so this object, the debug mod debug toolkit, yes, is scoped in memory with some other objects. There is a widget pool associated to him and a dynamic buffer also. So we can link some part of the object between them with the scope buffer. So it's help us to view something and to, for example, it was, do you remember what is it exactly? Yes, it was, the issue was 10 source code before when we saw it. For example, this, I will take an object shown selected for this OABL object. The issue for this one was 10 source code before. It was, for example, on this one, on this init entity which have the issue. So it was really hard to find it. We have this column there. Actually, it's unknown value, but if I select this, we have the number of occurrence of each line for each type, for this 31 type of issue, we will gather metrics on this one to know if there is, what I can say, to pinpoint one source code which has the highest number. So we can think that the issue comes from this one. I will try, but I don't know how many time it will take. Yes, as you can see, there is only one color on this element, but we are 26 on this one, 29 of this one, so there is a higher probability to find the root cause of the issue if this number is higher. So that's how we deal with actually.
Okay, so thank you for listening. Maybe you have any question? Yes, go on.
I just wonder why progress isn't better at the garbage collection of these objects that are left around. I'm thinking of a typical app server call, where you want at the end of the app server session, everything that's been created that was new to be freed up at the end of the session.
We would like that the garbage collector collect more objects than because it's its purpose also. But when you've got references between objects, sometimes the garbage collector doesn't collect the object. So that's why we've got memory leaks between the referenced object. So the session app server or not is not changing anything, and we've got those problems of memory leaks about that. So I don't know if that answer.
You can't always know, and there might be cases where with an app server you do want to load a series of procedures that you want to persist longer than that call.
Yeah. Also for managers, caching,
that
kind of stuff, so you can't just throw everything away.
No.
Yeah. Also, we don't show you, but there is some reusable object for static objects that we see in a few lines. So those static objects for the whole session that we don't want to delete, they are used again and again. So we also see in the view those objects, those static objects. So you can have a difference between those objects that you want the whole session than you can see right there. So those objects are objects for the whole session, so you don't want to throw them and to delete them. You can have those one, but the other one are not supposed to stay in the session, for us, at least.
This tool, is this something that you are willing to share, or is that just in-house tool?
It's in-house tool, but I will ask my boss and ask Progress if they are agree.
As we say, you can get the file, but that's that's easier with the that's easier with this view. Yes, please.
Is there documentation on the OEM file?
There is documentation. I don't know.
You have to ask to Progress.
I think Progress. I don't know what is given to all of us, because we've got it in beta, so we have a special documentation access. But I don't know. We didn't check what is allowed for everyone. Yes?
What we are seeing now, is that still beta, or is it part of 12.8?
It's part of 12.8. It's not beta anymore. We've got it in 12.7 just for us to
it was
beta.
Yes.
But you can use it. It's released.
Yes, yes.
Yes?
The objects and the references which are shown here also include event subscriptions. When you have an object A which gives an event and object B subscribe it, that you can see the reference between them both?
You can see the reference, but you don't have the call tree. so it could be not easy to find it, but you can see it.
Yes, and the backend exists still 12.8.0. It's just the front end, which is not, and they are still working on it on the backend and on the front end.
Do you also check for mem pointers?
Yes, you can see mem pointers, I
Yes,
think.
yes.
So, yes, you can see it. Yes, go ahead.
I think what's probably not there would be good. We use the request ID the logging to be able to tie all the logs together. If the OEMD file also included the request ID where the memory originated, then we can tie it back to the request that was being made. Do you use request ID at all in ads?
We don't use it.
It works with pass, but we don't use it at this time. But there is a field in each table, because on the DB, each table which is related to the pass, to the agent of the PassOE. So you can determine which agent it's or not.
Okay, because the request goes out.
Yes.
The request that came through, that's quite useful.
Yes.
It was not completely clear to me. Does it run on a database or in temp tables?
Sorry, can you repeat?
On a database, or is everything stored in temp table?
It's stored in temp table, but we've got also a database to put the files and to go through the analyze. But we just use it to store a tool share, but it's only temp table to this result.
In fact, on this part, I'm on the DB, and when I go on this view, I'll load everything from the snapshot of this session in temp table, and I'm working on temp table, which is faster, and it's allow me also to do diff and to have different view, which is faster to have directly I will say the consolidate data instead of the part of the data that I have to reconsolidate each time.
Another question? Yes?
Can you talk more about your use in production? So what is the overhead and do you have?
Can you speak louder?
Yeah, so I want to know more about your use case in production environment. There must be some overhead of enabling profile.
Each time 12.8 session start, it starts with a profile memory parameters. So we've got memory profile on each session,
So
which running under 12.8.
We have not all of our session in 12.8, so we have a lot of session in 11.7 currently. So that's why we don't have those analysis for every customer we have in production. But the 12.8 customers are analyzed every time, like said Patrice. So we can analyze problems when they raise when we want.
Do you have a frequency of traditional snapshots or it's manual?
No, we on production, it's a customer which launch it. So it's nothing manual, it's all defined by time, and I think it's 5 sec, something like this.
And for the analysis, we can't. We are not doing it every time. That's manual. Actually, we don't have automatic analyze. We just check if there is huge session, like Patrice said. But if there is small session with memory leak, we will not check those one because that's not the huge part of the problem. I don't know if I answer the question.
That's what I would do you have an estimation of the overhead of enabling? In terms of percentage, how much
it's around 5%. 3 and 5% of footprint on memory profiler. So for us, it will be okay. I don't know if for everybody it's okay, but for us, it will be okay, and we say go.
Thanks.
Something we do not say that when the session ends, we are moving the OMP file elsewhere, because it was a time where there is a potential issue when another session starts with the same PID as an old session. There is an OMP file which is the same name, and time to time it was not very good. So we move the file elsewhere. It's also to win some space. Yes?
You say that it's an issue with the PID because it's in your file name, I guess?
Yes, it's in the file name. I will go on when...
The definition of your file name done by you or by Progress?
It's us which giving... it's a report dir of the confile memory profiler. There is two parameters, the report dir and the number of seconds between two snapshots.
You can show it.
Yes.
If you want.
So, for example, so the session starts with profile memory. It's conf.mefprof, and yes, conf.mefprof. It's this one, and you've got report dir. It's what we are using as name. And if I go in this file, in this, and you've got memprof, the PID, and OMP file. It's always the same name. So when the name which still exists, it was a time or it could be bad.
Your question was about if we configure this file name or the...
I think what I understand now is that Progress defines the name of the file itself.
Yes. Yes. It's memprof.pid.omp.
Very good. Thank you.
Thank you.